about conditional statements. You're actually very used to conditional statements. You probably don't call them these, but you get conditional statements all the time. And they can take various forms. We'll talk more about that in just a second. But the definition is that a conditional statement is any sentence that can be written in the form if P, then Q. If something, then something else. Sometimes that's order. This has to happen before this happens. But sometimes it's like, if this happens, then I know this other thing is also true, which is the way we use it more. So for a sentence written in this form, the phrase after the word if, and I want you to underline after, it does not include the if, is called the hypothesis, and the phrase after the word then is called the conclusion. Now, let me give you an example before we do some of these. A conditional statement might be something like this. If I wear size 14 shoes, then I have trouble buying those in an ordinary store. True, right? Now, I want you to notice if I reverse the order, that may or may not be true. If I have trouble buying shoes in an ordinary store, it's because I have size 14 feet. Is that necessarily true? No, I may have some other foot problem that causes it. Like I may have one shoe that's, one foot that's an inch longer than the other one. Or have some other problem. So the order is very important in these. So, identify the hypothesis and the conclusion in each conditional statement. So, when it's in if-then form, it's pretty simple. The hypothesis is what comes after the if. And it is generally a sentence in itself. Today is Thanksgiving. Conclusion is the part after the then. Today is Thursday. For the second one, you have to be careful. Notice the if is buried in the middle. So, also you'll have to notice, and this happens a lot, that there's a pronoun here instead of the noun. When you write the hypothesis and the condition, we typically write the noun so that everyone knows exactly what we're talking about. So we won't say that the hypothesis is its measure is 130. We'll say, well, what? So the hypothesis, what is the it referring to? The angle. So I'll say an angle's measure is 130 degrees. Conclusion? No, there's no if.
It's obtuse.
Yeah, well, I'll go ahead and say, let's write it this way. The angle is obtuse. Again, this is a true sentence in the order that it's written. If I reverse it, though, if I said an angle's measure is 130, if the angle is obtuse, but that's not necessarily true. There's lots of obtuse angles. You can easily find a counterexample. So in symbols, if P then Q is written this way, P, and then you have this arrow and Q, which is read, P implies Q. So knowing P is true means that we know Q will also be true. And it's important that it's in that order. Knowing P is true lets me know that Q is true. If P is false, I have no idea what's going to happen with Q. All right, sometimes this has a temporal meaning, that once P happens, Q will also happen. In geometry, we frequently mean that if something belongs to the set of the things called P, then it also belongs to the set of things called Q. For example, here, dog implies mammal. As an if-then sentence, that would be if, and I'll say something, I don't like using it all the time, is a dog, then it is a mammal. And a Venn diagram for that would look like this. Everything that belongs to the set of things that are dog belongs to the set of things that are mammal. And that's a Venn diagram. By the way, actually I found most students, or at least somebody in the class usually knows, why is that capitalized? Yeah, it's a name. It's somebody's name. I don't know who originally it was. All right. So here, we want to write a conditional statement for each. Occasionally I have students complain that they don't know what some of the words are. It doesn't matter what the words are. Like on this one, people are like, what's a succulent? I don't know what that is. You don't need to know what it is. It says all of these are these. So if something, and I like using something for that rather than something more specific, is a succulent, then it is leafless. So knowing it belongs to that first group means that it also belongs to the second group. By the way, cactus and other things like that are succulents. Sometimes you'll do this from a Venn diagram. So if something is a robin, so if it belongs to this group, then it's necessarily part of the group of things that are birds. Then it is a bird. Okay. Here's where some students have difficulty, and I understand why you have difficulty. Conditional statements have a truth value of either true or false. Every conditional statement is either true or it is false. They are false only when a true hypothesis has a false conclusion. Remember, in an if-then statement, we're saying if the hypothesis is true, we know the conclusion will also be true. It doesn't tell you what happens if the hypothesis is false. So, let's take a look at these examples. Determine the truth value of each statement. If it is false, give a counterexample. So, if this month is September, then next month is October.
True.
Okay? That's a true sentence. If two angles are acute, then they are congruent.
False.
All right, can you give me a counterexample?
One could be 45 and one could be 35.
Okay. So this angle is 45. I'll try and make this one look a little smaller. And this one's 35. That is a counterexample. A counterexample is a concrete example. Sometimes students on counterexamples want to try and explain how it could happen. No, give a specific example. And then my favorite one in this set, if 9 is divisible by 2, then pigs can fly.
False.
It is absolutely 100% true. Because what?
They don't relate. So, but why is it true?
It's true because the only way a conditional statement can be proven to be false
Oh,
is if the hypothesis is true, but the conclusion is false. So, the example that I give to students is this one. If I win the lottery, I will give you each $1,000. Okay? What's the only way you can prove me a liar?
If you actually win the lottery and you don't give us money.
True hypothesis, false conclusion. That's the only way you can prove I'm a liar. If I don't win the lottery, can you prove that I lied? No. So if the hypothesis is false, then, well, we have to assume that this is a true statement because we can't prove it false. We can't find a counterexample. Okay? Now, some related conditional statements. First, we have to understand the negation of a statement. The negation of a statement either adds or takes away the word not. So, statement, I am tired. The negation is, I am not tired. Please be cautious about things like people try to think of opposites. They'll say, I am tired. The negation is, I'm excited, or I'm awake, or, I'm feeling full of energy, or whatever. No, it's just, I'm not. And then, if it already has not, you simply take it away. So if the statement says, you are not slow, the negation is, you are slow. It's an either or. This allows us to make several related conditionals. You will need to memorize these. The converse of a conditional statement switches the hypothesis with the conclusion. Remember, the if and then stay put. The hypothesis is what comes after the if, and the conclusion is what comes after the then. So we just switch those. The inverse of a conditional statement negates both the hypothesis and the conclusion. And then the contrapositive of a conditional statement both negates and switches the hypothesis and the conclusion. For me, personally, I always remember that one because it's the longest name and it's the one where you have to do the most stuff. So let's use the conditional statement, if an animal is a cat, it has 4 paws, to write the converse, inverse, and contrapositive, and find the truth value for each and for the original. So let's start with the original. And we're not going to go down the rabbit trail of, well, I saw a cat with 3 legs once, or whatever. I'm talking in its natural state. If an animal is a cat, then it has 4 paws. True or false? True. All right, so now let's do the converse. If an animal has 4 paws, notice I'm replacing the it with an animal, because that's what it referred to. Then it is a cat. Okay, prove it.
Dog can have 4 paws.
Yeah, this is false. Dog is a counterexample. A bear would be another counterexample. Lots of mammals. All right, the inverse. For the inverse, we're going to negate both parts. So if an animal is not a cat, then it does not have 4 paws. So to find a counterexample, you need to find something that's not a cat that does have 4 paws.
Dog.
Well, yeah, dog still works, doesn't it? And then the contrapositive. We're going to both negate both parts and reverse the order. So that would be if an animal does not have 4 paws, then it is not a cat.
True.
That's a true sentence. If it doesn't have 4 paws, well, that's not a cat. Yes.
What if the cat got rid of
Okay, that's what I said. We're not going to go down that rabbit trail. We're talking about it's biologically designed to have 4 paws. But yes, you're right. There are all kinds of exceptions to that. So logically equivalent statements are statements that have the same truth value. So notice our original and the contrapositive were both true. So a statement and its contrapositive have the same truth value. They are logically equivalent. A converse and an inverse are also logically equivalent. And the reason for that is, if you think about it for just a second, if I started with the converse on this one, the contrapositive of the converse would be the inverse. And a statement and its contrapositive always have the same truth value. Now, sometimes all of them will be true, and sometimes all of them will be false. Okay? But you always know that the original and the contrapositive will have the same truth value, and the converse and the inverse will have the same truth value.